All right, so we left off in the middle of 6.5. We were almost done the first half of it. We just have a few things left to finish, and then we'll start the second half, but I'm not sure we'll finish that today. Okay, so in this problem, they want us to find the 6 trig functions of 45. And that's all they gave you. They didn't give you a diagram. So if you don't know the 6 trig functions of 45 off the top of your head, which you might not, you're going to have to draw some kind of diagram to help you do the opposite adjacent and hypotenuse. So there's a diagram. But what's missing in that diagram? Yep.
The side length.
I didn't give you any side lengths. You've got to figure the side lengths out yourself. What did we say yesterday? When you do trig functions, does the size triangle you use matter? No. Whether you use a small 45, 45, 90 or a big 45, 45, 90, you're going to get the same answers. You do need to label the sides properly, but there's an infinite amount of triangles that have a 45, 45, 90. We want to try to pick the easiest one that we can to work with. What do we know about the sides in a 45, 45, 90? I think we might have mentioned this before. It's a special kind of triangle. It's a right triangle, but it's also something else. Yep?
The 2 legs are the same length.
Right, the 2 legs are the same length. So pick a number that you want to use for the 2 legs. Just make them the same. What should we use for the length of each leg? That would be an easy number to work with.
2.
2? All right, you could pick 2. That would be fine. What would be even easier? There's nothing wrong with 10. You could. I think that would be a little harder because it's bigger. Yeah? Yeah, I would just make each one of them 1. 1 and 1. So you can pick anything you want. They just have to be the same. And how would you figure out the hypotenuse? Yeah.
A squared plus b squared equals c squared.
Yeah. So if you use the Pythagorean theorem, what does the hypotenuse come out to here? Yep. Won't come out to 2. Yeah?
And they come up to 1.
No, that's not an equilateral triangle. All sides are not the same in that triangle.
Oh. Square root of 2.
It comes out to the square root of 2 if you use Pythagorean theorem. Any question on that? Yeah.
Could you do that out, please?
So you'd have 1 squared plus 1 squared equals c squared.
The square root comes from the c.
Add the 1 squared and 1 squared,
Okay.
and then take the square root of both sides. Okay, all the other numbers you guys were saying for the sides, like if you used 2 and 2, that would have been fine. It would have just been a larger version of my triangle, and it would have worked the same. All right, now they want to know the 6 trig functions of 45. So the next thing is you need to pick your reference point in this triangle. What should our reference point be, like the perspective in the triangle? Yep.
45 on the left.
Why not the 45 on the top?
I just like 45 on the left.
You like the 45 on the left. Could I do the 45 on the top? Yeah, it's the same thing because when you look at the side that's across from the 45, it's going to be a 1 no matter which one you pick. So pick one of the 45s, and now we can go through all the functions. Let's start with the sine. What is going to be the sine of 45? Yep.
1 over square root of 2.
Yep, it's going to be 1 over the square root of 2. That's opposite over hypotenuse, but we have to fix it so there's no root in the bottom. What do we get when we fix 1 over the square root of 2? Yeah.
Square root of 2.
Square root of 2 over 2. Perfect. Okay, let's do the cosine. What's going to be the cosine of 45 degrees?
So it's also square root of 2.
Yeah, it's also square root of 2 over 2 because cosine is adjacent over hypotenuse. But opposite and adjacent are the same. So it's going to be the same answer. And how about the tangent of 45? Yeah, those? Yeah, that's going to be 1 because tangent is opposite divided by adjacent. 1 divided by 1. Okay, so there's the tangent of 45. And the next one, cosecant. So what are we going to do with the 3 that we have now to get the 3 that are on the right? Yep. We just flip them. Yep. So we've already got something we could flip from the work we had earlier that's going to make the cosecant of 45 very simple. Yeah.
You flip the original equation of sine 45, so it'd just be square root 2, right?
Yeah. If you flip what's in that box, which is equal to what's circled, the advantage is the root goes to the top and you're done. So the secant is square root of 2. How about, I'm sorry, the cosecant. What about the secant? Yeah.
Is it square root of 2?
It's also square root of 2 because the sine and the cosine are the same. And lastly, the cotangent of 45. Yeah. 1. So if I ask you to find the 6 trig functions of 45 degrees, those are the answers. But if you forget them, you should be able to draw your own 45, 45, 90 triangle and figure them out if you had to. The size of the 45, 45, 90 doesn't matter. If you did a 2 and a 2, then this would be square root of 8, because it would be 2 squared plus 2 squared, which is 8. And then you take the square root. So it would all reduce to the same numbers. All right, so 45, you can figure that out on your own. The other one I want to look at is the 6 trig functions of 30 and 60. Again, I'm not going to give you a diagram. What kind of triangle has 60-degree angles in it? Yep.
Is that obtuse?
An obtuse could have a 60-degree angle, but I'm looking for a triangle that has only 60-degree angles. Yep. Even more than isosceles. Yeah.
Equiangular.
Yeah, equiangular is a triangle that all the angles are the same, and if they're all the same and have to add up to 180, they would all be 60. So that's the diagram we're going to start with. We're going to start with an equilateral or equiangular, same thing, triangle. Now, one thing that we're missing is side lengths. We have to pick a number for each side. Okay. How many different size equilateral triangles are there? There's infinitely many. You can use any one of them to do this problem. But ideally, we want to pick the easiest one. Anybody have a suggestion for the side lengths? Yeah?
1.
So last time I thought 1 was a good idea. We could use all 1s. It would be okay, and it would work. But I think there's a number this time that's going to be a little bit easier to use. But not 1. Anyone have another guess? Yep.
3.
No, not 3. One more guess? 2. Yeah, I'm going to use all 2s. Any of the other numbers you guys said would have worked. But watch why I'm going to do all 2s. Now, I'm trying to work with a right triangle, and I need to create a right triangle that has a 30, a 60, and a 90 in it. Okay? Trig doesn't work the way I taught it to you unless you have a 90 in the problem. Right now, we don't. How could I do something in this triangle to create a 90-degree angle and a 30-degree angle? Yeah.
Like a line down the middle.
Right. You could put a line from this vertex perpendicular to the opposite side. And in geometry, you could prove that if you draw a line perpendicular from a vertex to the opposite side, it creates 2 congruent triangles. The one on the left and the one on the right are mirror images of each other. So this is a 90. What else do we know? Yep.
The 2 angles at the top are both 30.
Right, 2 angles at the top are both 30. So now we're focusing on this triangle right there. What else do we know about that red triangle? Yep.
The bottom length is 1.
Right, the bottom side is 1. And we know that because these 2 triangles are congruent. They're mirror images of each other. So if this is equal to that, and together they add up to 2, then individually they must each be 1. That's why I picked 2 for all the sides, because I knew I was going to be cutting one of them in half. If I had picked an odd number, like 1, for the whole side, well, then you would have had a 0.5 and a 0.5. It's not that bad, but we just avoided the fraction. Okay. All right, so now there's one more thing we need. We need the height of that triangle. What would be the height of the triangle using Pythagorean theorem? Yep.
Would it be square root of 5?
It is going to be a square root, but not 5. You need to subtract instead of add because you're bringing something to the other side in the theorem.
Square root of 3.
It would be square root of 3, yeah. Because now if you square this, you get 1. If you square that, you get 3. 1 plus 3 is 4. Take the square root. 2. Okay, so that's the hard part. Now we've got the diagram. We can figure out all the trig functions for 30 and for 60. All right, so let's write them down. Sine, cosine, tangent, cosecant, secant, and cotangent. Right. So reference angle to start this problem is the 30. So pretend like you are standing there. What would be the sine of 30 degrees? About Gabby, what would be the sine of 30 degrees?
No idea.
Okay, what's the definition of sine?
I don't know how to definition. But
Anyone help her out?
do you need like a formula
I guess it's a formula. It's a fraction. Yep. So yeah, it's opposite over hypotenuse, which in this case is 1 over 2. Okay. How about, Luke, what's the cosine of 30? what's the formula for cosine?
Opposite.
That's sine. We want cosine. Anybody help us out? What's the formula for cosine? Yep. Yeah, adjacent over hypotenuse. So what's the adjacent in this problem?
1.
So lose.
Oh, my
Oh. The adjacent. That line down the right.
We're looking at the red triangle.
I'm looking at the wrong one. Okay. Square root of 3.
3. And what's the hypotenuse? 2. So the cosine is root 3 over 2. Okay, tangent. What's my formula for tangent? River?
Opposite over adjacent.
Okay, so in this case, that would be
So would it be 1 over 3, the square root of 3?
1 over the square root of 3. And then when you fix it,
It would be square root of 3 over 3.
square root of 3 over 3. Okay, so we got the first 3. Jack, what would be the cosecant?
Cosecant is going to be 2 over 1. Or 2.
2 over 1, which, yeah, we're just going to write as 2. How about the secant of 30? Final answer. Yeah.
2 square root of 3 over 3.
Yep, 2 square root of 3 over 3. And what about the cotangent? Yeah,
Just be the square root of 3.
just be square root of 3. Now, to do the 60, we're going to see some very similar answers because it's the same triangle. We're just switching our perspective. So now you're here instead of here. So what switches when you switch your angle? Yeah,
Opposite and adjacent.
opposite and adjacent, switch places. And cosecant, secant, cotangent. All right, let's start with the sine. What's the sine of 60 degrees? Yeah,
Square root of 3 over 2.
opposite over hypotenuse, root 3 over 2. What about the cosine of 60? Yeah,
1 over 2.
1 over 2, adjacent over hypotenuse. And the tangent of 60. Yeah,
Square root of 3
square root of 3.
over 3. I think. No. Over 4. So
Oh.
square root of 3.
Say it one more time.
It's square root of 3.
Square root of 3, yeah, it's just square root of 3. Okay, how about cosecant? Yeah,
Is it 2 square root 3 over 3?
2 root 3 over 3. Yep. The secant? What will that one be, Chris? 2. And lastly, the cotangent of 60 degrees. Yeah,
Square root of 3 over 3.
that's square root of 3 over 3. So if you look at the 12 answers we got between the two problems, they're all the same numbers in the problem on the left and the problem on the right. They just appear in different spots because opposite and adjacent switch places. Yeah.
Can you go over the tangent and cotangent real quickly, the 60?
The tangent and cotangent of 60?
Yeah.
So the tangent is opposite divided by adjacent.
Okay.
So root 3 over 1. And then the cotangent is when you take what I just said
Flip it.
and flip it. So it's 1 over root 3,
And then out, okay.
but you can't leave the square root in the bottom. So when we fix it, it becomes root 3 over 3. Okay, for all of these kinds of questions, it's never going to ask for decimals. Okay, that is how you're going to write all the answers when they ask for trig functions. Okay. You don't always have square roots. Some answers might not, but some answers might. All right, any questions on that? Other than 30, 60, and 45, you wouldn't really be asked to find the trig functions of an angle without me giving you a diagram. Okay? So angles other than those 3, I'll give you some kind of diagram to work with. All right, so when we draw a right triangle, something like this, how come angles 1 and 2 are complementary? Why? We've kind of talked about this in different ways. Yep.
Because they add up to 90.
Right, they have to add up to 90, because all the angles add up to 180. This is a 90. So together, those two have to be a 90, or the whole thing's not going to add up to 180. Yep. All right, so when we are drawing a generic triangle that we don't know anything about, we generally use A, B, and C for the sides. A and B are the legs, C is the hypotenuse, nothing new there. But when we don't know the angles, a lot of times we use Greek letters. So that's going to keep it clear what's what. I don't like using English letters for the angles, because sometimes what a book will do is it'll use like a capital C for a side and a lowercase c for an angle. Well, to me, a capital and lowercase c can look the same. So that can be confusing, unless you have other letters to see how big it is compared to those letters. So Greek letters for angles, English letters for sides. That's how we'll do it. Yep.
Just scroll.
Thank you. So this Greek letter is, what's the name of that one?
Which one?
The one in the lower right. We talked about it, maybe I had like 5 of them on the board one day, and I said we'll use all these Greek letters eventually. Yeah.
Sigma?
No, it's not a sigma. Sigma is used in math. Not in this class. Well, no, actually, when we get to chapter 11, we use that. But it's totally different. So no sigma here.
Is that alpha?
That's an alpha. Yep. So we have alpha across from A.
No.
And what about this Greek letter? Beta across from B. Okay, that's purely a convention we use to try to keep everything organized. A across from alpha, B across from beta. If you want to draw your triangle facing a different way, no problem. You can draw it like that if you want. Just make sure wherever you put A, put alpha across from it. And wherever you put B, put beta across. All right, so now let's try finding the sign of alpha. Okay, it's not going to be any numbers in this. What would be the sign of alpha using the triangle up above? Just the one right above it. Yeah.
It would be A over C.
Yeah, A over C. Here's another problem. What would be the cosine of beta? Yep. What's the definition for cosine again? Yep. adjacent over hypotenuse.
Oh, wait. So that's, hold on, I gotta like look. Does it include B and C? Or am I lying?
Partially.
Okay, so there's a C. Okay, so there's a B. Okay, there's a C. And, all right, that's all.
Yeah.
Would it be A over C again?
That would be A over C. This is adjacent. That's hypotenuse.
I was close.
How about, let's do this one. Tangent of alpha. What's the tangent of alpha? Yep. A over B, opposite over adjacent. Now I'm going to make up another problem. Cotangent of beta. Cotangent is adjacent over opposite. Yep,
Is it A over B?
that's also A over B. So there's a reason why the one on the left and the one on the right are coming out the same. Look at the name of the trig function. Sine, cosine. Tangent, cotangent. So the pairing of the trig functions is the one with co and the one without co.
Bless you.
So I could do one more. I could do secant and cosecant.
Okay.
So that's the pairing of the trig functions I used. And then what do we know about alpha and beta? What did we just say about these two angles? They're complementary. So this is called the complementary angle theorem. Very simple idea. It says that if you have cofunctions, that's what sine and cosine are called. Tangent and cotangent. Secant and cosecant. These are cofunctions. Sine, cosine, tan, cotan, secant, cosecant. If you have cofunctions and the angles are complementary to each other, meaning they add up to 90. This angle plus this angle. If they add up to 90, the answers that you get will always come out the same. All right, so let me show you why two things coming out the same could really help us to figure out a problem. I want to simplify that. The sine of 35 minus the cosine of 55. If you're trying to figure this out by thinking of what the sine of 35 actually is and what the cosine of 55 comes out to, you're not thinking about it the right way. We're never going to actually know what this is or what that is. But that still doesn't stop us from figuring out what you get when you subtract the two. Sine, cosine. What are sine and cosine? Yep.
They're complementary.
No, complementary only applies to numbers. These are function names. Yep. These are co-functions. Sine, cosine. How about 35 and 55? What kind of angles are those? Yep. They are acute. Thinking of something that I mentioned today, though. But yes, they are acute. Yep. They are complementary. If you add them together, you get 90. So we've got co-functions, and we have complementary angles. So what do you know about this and that?
I don't know.
Yep.
But they're the same.
They are the same thing. Co-functions, complementary angles. If you have two things and you have co-functions of complementary angles, they are the same thing. So what would you get when you subtract sine 35 minus cosine 55? Yeah, 0. Yeah. I don't know what either one of those boxes is, but I know they're the same thing. And when I subtract two things that are the same, I get 0. Right. How about this one? Tangent of 20 divided by the cotangent of 7. Anybody know what that one's going to come out to? Yeah. Yeah, that's going to come out to 1. Can you explain why it comes out to 1? True, but why are they the same? I didn't tell you they're the same. Because what? Well, we wrote something up above, but we got to explain, does this thing we even wrote up above apply here? That's what we have to explain. Yeah.
Because they're co-functions.
These are co-functions.
And their angles add up to 90, which
And-
means they're complementary.
Yes, and these angles add up to 90. So we have co-functions of complementary angles, which means, yes, you can apply this theorem, which says that these two things we're dividing are equal. And when you divide two things that are equal, you get 1. Yeah.
It can be like any combination to make it complementary.
10 and 80, or 89 and 1. Yep. Yep. Any two numbers that add up to 90. Now, if this was like a 22 and this was a 70, then no. We don't know what this would come out to because the theorem doesn't apply. It wouldn't be a problem you could do in your head. Any question on that? Okay. All right, so the last thing we're going to look at in 6.5 is how to solve a triangle. So we've been drawing a lot of triangles. We haven't really solved any yet. Solving means to figure out how long is every side and how big is every angle. So there are 6 things. Can you just wait for one person to come back? Yeah, thank you. So there are 6 things that you have to figure out. 3 sides and 3 angles. But based on what I wrote up on the board, what is something that you think you're going to know about every triangle automatically? Yeah?
If it's 90 degrees or not.
So what are you going to know about every triangle that I give you?
Whether it's 90 degrees or not, like one angle is 90 degrees.
One angle is 90 degrees, yes. So out of the 6 things, now you're down to 5. And one angle will always be 90 degrees. Now, in order to solve for the things that you are missing, I have to give you 2 more pieces of information in addition to the 90. So you already have the 90. But I could either give you another angle and another side, and that's enough information to figure everything else out. Or I could give you both of the sides. I couldn't give you both of the angles. That would be like me giving you all the angles in a triangle, like saying, okay, I'm thinking of a triangle. All the angles are 60, 60, 60, 60. How big is each side? Well, 60, 60, 60 means it's equilateral, but they could be any. 5, 5, 5, 10, 10, 10. You always have to know a side. Always. Without a side, you have no reference of size. So it'll always be one of these 2 cases. We definitely won't get to the second case today. So a couple things that we can use when we're solving triangles. The Pythagorean theorem is one formula that we'll use. And the other fact we can use is all the angles in a triangle add up to 180. We won't be using radians, so you don't have to worry about any kind of conversion between radians and degrees. It's all degrees. What are the 3 trig functions we have buttons for on the calculator? 3 we do, 3 we don't. Yeah?
I know we have sine and cosine.
We have sine and cosine. Anything else? Yep.
Tangent.
And tangent. Because we have sine, cosine, and tangent, as buttons built into the calculator. Those are the only 3 trig functions we're using in this part. It's not that we couldn't use the secant, the cosecant, and the cotangent. It would just be more complicated with the tools we have available. Okay, so we're going to stick with sine, cosine, and tangent. You're not using all 3 of these trig functions in every single problem. Most of the time, you're only going to use 2. You have to figure out which 2 you need to use. The way you're going to figure out which 2 you need is going to be based on what information did they give you in the problem and what information are you trying to figure out. Do you know the opposite side? And maybe they want you to find the adjacent. Well, if you know opposite and you're trying to find adjacent, opposite and adjacent is tangent. If they give you opposite and they say find the hypotenuse, you've got to think, okay, opposite hypotenuse, which trig function is that? Sine. Right. So we're going to look at the sides and we're going to figure out which trig function to use based on that. All right, so let's see if we can solve this one. Now, in example 1, they're a little bit vague. They just say that one angle in a triangle is 37. They don't tell you which one it is. It could be alpha, or it could be beta. On the test, I will tell you which one it is. It's not really significant. If you call it alpha, and I call it beta, we're still going to get all the same answers. It's just my answers and your answers are going to be in different spots. But they would be all the same. All right, so the first thing that we want to do anytime we're solving a right triangle problem is make a sketch. Because we need to figure out what's opposite and what's adjacent. After you've done a few thousand of these, you can probably visualize it in your head. There's opposite, there's adjacent, you just kind of can see it all. But I would recommend making a triangle like that at first. Okay. And label everything using the blanks. A, B, C, alpha, and beta. And now start to fill in what we can. One of the angles is 37. Do you want to make that alpha or beta? We do have to choose.
Beta.
Okay, so that's going to be our beta. So 37. And then it says the hypotenuse has a length of 8. Well, you don't have any choice about that. Which letter is going to be equal to 8? Yes, C. Okay. So what I'm going to do is I draw the diagram so I can visualize it, and then down below I'm going to make a table. Okay, I know beta is 37. I know C is 8. And I'm going to put boxes around everything I need to figure out. A, alpha, and B. So when we're done, I'm looking for 3 answers to this problem. Okay, is there anything that we could find relatively quickly in this problem? And hopefully you could have done this before I taught you anything about trig this week. Yep.
Alpha, angle of alpha.
Right, we should be able to get the angle of alpha because we know they all have to add up to 180. So what is alpha going to be? Yep.
90 plus 37 minus 180.
Okay, you can think of it as 90 plus 37 and then subtract that from 180. Or you could, what would be even a simpler calculation? Yep.
You can just do 90 minus 37.
Right, we know these two have to add up to 90. So just figure out the difference between 90 and 37, which would come out to 53. Okay. So there's our first angle. We have two things left to find. When you're solving a right triangle, the order that you solve for the unknowns does not matter. You can find anything you want in any order you want. All right. Now let's do A next. All right, so to find A, first thing we have to do is pick an angle to be our reference point. Without a reference point, we can't do anything. What angle should we use as our reference point? The 37, which was beta, or the 53, which was alpha? Yeah.
53.
Okay, why would you want to use the 53?
Is it because it's on the opposite side from A?
It doesn't really have to do with the position of where it is. It has something to do with something else, though. Yep.
You see, you have to always associate A with alpha.
So which angle did you want to use, the 37 or the 53? It does. You could use either one to find A.
Oh, okay.
You don't have to use a certain one, but I strongly suggest a certain one. I'm trying to see if somebody can figure out why. I just want to know why I should use the 37 or the 53. What's that? To find A.
Oh.
Either one would work. But there's one I definitely would caution on using. Yes?
Is it the 53 because it would like kind of A would be like the hypotenuse for that angle?
No, A is definitely going to be opposite or adjacent.
Okay.
It won't ever be hypotenuse. That's
I was
always
just-
C.
I just didn't. Never mind.
How would you tell us which one and figure out why?
I would use the 37.
No.
What are the...
Does it have to do with the 90?
No, it doesn't really have to do with the 90. Why would I use the 37? Yeah?
So you can use sine and cosine as like code.
I'm not even thinking about trig functions I'm going to use yet. I will be. That's my next step. But up to this point, I haven't given any thought if I'm using sine, cosine, or tangent. That doesn't play into why I chose 37 at all. Yep.
Is it because it was a given?
Why? What would that matter?
I have no clue.
Okay. Yeah?
Is it because the one that we calculated could be wrong, so we use the one that we know 1,000%?
Right. If you use the one that you calculated and it's wrong, then everything you use it for is going to come out wrong. We know the 37 is right. So you were right. I was just hoping you would say why.
Yeah.
The 37 was given. It's guaranteed to be correct. So always stick with the information that was given. So we need an angle. That's our perspective. We also need to use a side. What side could I use that I know? Yeah. It's the only one I know. So I have to use the 37 and the 8. That's the given information. That's what I'm trying to find. Every trig function is going to involve 3 things. 2 things you know, 1 thing you don't. Always. All right. Now I need to start thinking about trig functions. What's the name of side C? Or let me ask a better question. What's the position of side C in this triangle? It's hypotenuse. Yep. And what's the position of side A relative to 37? Yep. This is adjacent. And we don't need it yet, but we will when we finish it in a minute. What's the position of side B? That is opposite. Okay. So don't worry about B yet. All right, we're trying to find the adjacent, and we know the hypotenuse. What trig function has adjacent and hypotenuse? It has to be one of those three that I wrote right there. So which one has adjacent and hypotenuse? Nick? Cosine. So let's make our trig function. Cosine. Leave room for the angle you need to fill in. Okay, that's called the argument. You always have a fraction on the other side. What is the angle that I'm filling into cosine 37? Yep.
37.
I mean, what's the angle I'm filling into cosine? Yeah, 37.
Let's go 37.
Yeah. So we got the cosine. Cosine of 37, adjacent over hypotenuse. Okay. What's the adjacent? Yep. A. And what's the hypotenuse? 8. Now we just have to get A by itself. How would you move 8 to the other side? Yeah.
Multiply.
Yep. Multiply by 8. Multiply by 8. And we're going to put that in on the calculator. 8 cosine 37. 8 cosine 37. Make sure you are in degrees because 37 is a degree. So switch to degrees. 6.389. Okay, we'll generally do 3 decimal places. Okay. Now, we know 2 out of 3 of the sides. What could we use to find the third side? Yeah.
The Pythagorean theorem.
We could use the Pythagorean theorem, but why do you think I'm going to say that's not a good idea? Yeah.
Because A has a decimal.
Okay, A is a decimal, yeah. What else about A? Yeah,
We calculated it.
we calculated it.
It's not a given.
It's not a given, could be wrong. So if we use Pythagorean theorem and A is wrong, then now B is wrong. Right? The way I'm showing you how to do this, you could make a mistake on one part and it won't affect anything else because we're always going back to the given. So we were given the 37, we were given the 8, and now we want to find B. Side B is opposite. That's what we want to know. Side C is hypotenuse. So look at the 3 things circled in blue. That's what we're using now. Opposite and hypotenuse. What trig function involves those two? Sine. So trig function, angle, fraction. That's how it's always set up. What am I going to fill in for the angle? Yep. 90 can never be a reference angle.
Okay.
The 90 is not circled, so we can't use 90. We're using the reference point. Yep.
37.
It's the 37. Yep. So this always has to be a number smaller than 90 this week. Opposite. What side is opposite? B. And what side is the hypotenuse?
C.
C. And same way, we got A by itself up above. Times E. Times E. Okay, type that in, and that'll tell you what B is. 8 sine 37. 4.815. Now, if you had extra time and you wanted to make sure that you're doing it right, you could type into your calculator a squared, type in b squared, add them together, and then calculate c squared. A squared plus b squared should be about 64 in this problem. If that checks out, then you know you did it right. Okay. Any question on that? All right. Let me put up the homework. We got a couple to finish, and we'll do that tomorrow.
Oh,